Hello everyone, I am Venkat, a first year student at Sri Venkateshwara College of Engineering, pursuing BE in Computer Science and Engineering. Subject Applied Physics for CSE stream. Topic Monte Carlo and Normal Distribution Method. So let's get started. What is Monte Carlo method? The expression Monte Carlo method is actually very general. Monte Carlo methods are based on the use of random numbers and probability statistics to investigate problems. You can find MC methods used in everything from economics to nuclear physics to regulating the flow of traffic. A Monte Carlo method is a way of solving complex problems through approximation using many random numbers. They are very versatile but are often slower and less accurate than other available methods. There is no single Monte Carlo method. Instead, the term describes a large and widely used class of approach. Essentially, the Monte Carlo method solves a problem by directly simulating the underlying physical process and then calculating the average result of the process. Because of their reliance on repeated computation of random or pseudo-random numbers, these methods are most suited to calculation by a computer. However, these approaches tend to follow a particular pattern, define a domain of possible inputs, generate inputs randomly from a domain using a certain specified probability distribution, perform a deterministic computation. This means that given a particular input, it will always produce the same output. Using inputs, then aggregate the results of the individual computations into the final results. Use of Monte Carlo method. They tend to be used when it's unflexible or impossible to compute an exact result with a deterministic algorithm. More broadly, Monte Carlo methods are useful for modeling events with significantly uncertainty in inputs, such as the calculation of risk in business. Advantage of this method over other technique increases as the sources of uncertainty of the problem increases. Monte Carlo methods are particularly useful in the valuation of options with multiple sources of uncertainty or with complicated features which would make them difficult to value through a straightforward black school style computation. The technique is thus widely used in valuing exotic options. In most basic terms, draw a random number, process this random number in some other way, for example, plug it into an equation. Repeat step 1 and 2 a large number of times. Analyze the cumulative results to find estimation for a non-random value. Example of Monte Carlo is as follows. Monte Carlo calculation of pi. We'll use the unit circle circumscribed by square. However, it's easier to just use one quadrant of a circle. So, calculation of pi. So let's pretend you are a Hollywood dart player. The worst, every throw is completely random. Now imagine throwing darts at the unique circle. Because your throws are completely random, the number of darts that land within the shaded unit circle is proportional to the area of circle. In other words, number of darts hitting shaded area divided by number of darts inside the square equals area of circle by area of square. If you remember your geometry, it's easy to show. So number of darts hitting shaded area by number of darts hitting inside the square equals 1 by 4 pi r squared divided by r squared, that is equals to 1 by 4 pi. This can also be written as pi equals 4 into number of darts hitting shaded area by number of darts inside the square. If each dart thrown lands somewhere inside the square, the ratio of hits in the shaded area to throws 1/4 value of the pi. Moving on to normal distribution, a symmetrical probability distribution where most results are located in the middle and few are spread on both sides. The normal distribution is most important and most widely used distribution in statistics. It is sometimes called as the bell curve. It's also called the Gaussian curve, after the mathematician Carl Friedrich Gauss. So this is the bell curve as shown in the diagram. Normal distribution properties. A continuous random variable x is said to follow normal distribution if it satisfies following property. If it is bell-shaped curve, The curve is symmetrical and asymptotic, that is, it never touches to the x-axis. All measures of central tendency are equal and stable on the highest peak axis, that is mean equals median equals mode. Total area under the curve is equals to 1. On the basis of mean, nu and standard deviation, sigma, the area of normal curve is distributed as shown below. Standard normal distribution. Standard normal variable z score. Any normal distributed data can be converted to a standardized form using the formula z equals x minus nu by sigma. If we take x equals nu, then we get 0, z equals 0. If we take x equals nu minus 1 sigma, then z equals minus 1. If we take x equals nu plus 1 sigma, then z equals plus 1. If x equals nu plus or minus 2 into sigma, so z equals minus 2 plus 2 and etc. Normal distribution properties. If it is asymptotic, that is, it never touches the x-axis. All measures of central tendency are equal and stable at the highest peak axis, that is mean equals median equals mode, that is equals to 0. Total area under the curve is 1. On the basis of mean, mu equals 0 and standard deviation sigma equals 1. The area of normal curve is distributed as 68% of observation lie within minus 2 plus 1. 95% of the observation lie between minus 2 to plus 2. 99% of the observation lie within minus 3 to plus 3. In a nutshell, I would like to say Monte Carlo simulations excel in handling complex, uncertain scenarios, while the normal distribution method is effective for more predictable data sets. Their complementary strengths make them valuable tools for informed decision making, offering versatility and precision in various applications. Thank you. Bye bye.